In this video, we're going to learn how to use R without the fluff, just R. You can download the program for free from the R website, and installation should be straightforward on most computers, be this Windows, Mac or Linux. R is a popular software package for quantitative analysis, including graphics. If you explore R on the internet, you'll find many interfaces and development environments that are meant to make R more accessible. Popular choices are RStudio, Visual Studio, Positron, Jupyter, RKWord or R Commander. Many of them offer useful functionality, but the choice can be confusing. After all, you probably just want to run a cross table on this dataset, right? The good news is that you don't actually need these development environments to use R. I'm not arguing against these programs that integrate R. They're actually great, but it's an additional layer and some find it less helpful, especially at the beginning. By all means, try them, but the basic use of R doesn't change. Today we're using plain R, as you can download it from the R project. When you first open R, it looks something like this. Let's have a peek around to see what's where and explore how to use R. Perhaps the most unexpected thing of software like R is that we principally use text rather than point and click to use it. This sets it apart from programs like SPSS, JASP or PSPP that may feel more like spreadsheets. Once you get used to the idea though, using text is actually quite efficient. On the one hand, we can use text a bit like with a chatbot or with a calculator. We can use the text windows referred to as the console. Rather than using natural language, we have to use a specific way, a language called R. This allows us to be precise about what exactly we want from the program. Let's try it. So we can ask R to calculate 4 plus 2, and it returns the result like a calculator would. Here the first result is 6. So that's why we get this 1 in the square brackets. Typically we use specific words to tell R what we want. For example, if you wanted to know the square root of 42, there's no square root button on your keyboard, right? Instead we type SQRT, which is short for square root, and 42 in brackets. These are commands, like we can print the word hello on the screen by using the command print, brackets for the details about what we want to print, that's the word hello in quotes. So we also have a command and brackets for the details. This is the basic way we can communicate with R. Most of us have preferences about how we work. R can be modified a fair bit if you head over to the menu Edit and the graphical interface preferences. You don't have to change anything, especially not if you're here for a quick calculation of the mean, but it's nice to know what's there. I think the biggest change you might want to do is choose between MDI and SDI. That's whether you want one big window for R with separate smaller windows for the console and graphics, or whether you prefer separate windows that mix with other programs you might have open. This is purely personal preference. You can also change the language of the menus and messages here. Beyond that, you can change the font and colors to your liking. None of these settings has a consequence on the calculations in R, so tweak them if you like. If R cannot save the default settings, use your Windows Explorer or Finder to find a document called R Profile. Open this file in a text editor like Notepad, Notepad++ or TextEdit and update your preferences there. As we've seen, at its core, R is a calculating machine and we use text to communicate. If this is a bit uncommon at first, you'll quickly learn that using text is a very efficient way to communicate with the machine. Basically, you can reuse your code, adapt it in a flexible way, and you'll find it much easier to figure out what you actually did. To do this, the simplest way is to use a separate window with the code, or a script as we often call it. You can use Menu File, New Script. A new window appears where you can write your instructions for R. Doing so allows you to copy and modify existing code and adapt it to your needs. For example, if you already have code to import data and create a cross table, you can copy this code and adjust the name of the dataset and the variables. It's easy to come back to an analysis at a later stage and make changes or add new bits. So we can use the instructions, commands like print, and then use Ctrl R or menu edit and run line or selection. If there are results to show or a graph to display, R will do so in the console or in a separate window for graphs. When using a Mac, it's Ctrl plus Enter. R for Linux doesn't come with a graphical interface, but you can use a Genie in pretty much the same way. That's better than copying and pasting into a console. In sum, use a separate script, send commands to the console using Ctrl plus R. Let's do a simple example to run through the basic motions. We open R. Depending on the settings, we have the console in a separate window or within a bigger window. This makes no difference. Let's get some data into R. For this example, we'll use a comma-separated document, a document ending in .csv. Before I start, I check where the document is using Windows Explorer or Finder. That's important because R always looks for documents in a specific folder, the working directory. We can change the working directory using menu File, Change Directory. In the new window, we navigate to that folder where the data are stored. Alternatively, setwd does the same, like setwd desktop. The slashes face forward, so you might find it easier to use the menu. When I get an error importing data, it's typically because I forgot to set the working directory. If you look for how to do things in R on the internet or in a book, what you'll be given is code, the script. To use it, start a new script. That's menu File, New Script. We can then paste our code from the internet, from code we have written previously, copied from a book, or just write our own. When reusing code, it's important to adjust it to the project at hand, change the variable names, etc. Let's do this with our example. We open a new script window, then we add code to read data from a CSV file. At the beginning of the line, we have dat equals. Dat is the name of an object. Here the object of the dataset we import. It's like putting the data into a box and putting that box on the shelf so that we can use it later. To remember which box we use, we give it a name. Here I chose dat, but you can also use my data or data1, whatever. Naming objects makes no difference to the results, it's just for you to remember. Just make sure you write the names in exactly the same way. For R, dat with a capital letter is different from dat with a minuscule. To the right of the equal sign, we have the command to open a CSV data file, read.csv, followed by brackets. In the brackets, we write the name of the CSV file in quotes, so myfile.csv. Pressing Ctrl R, we can ask the machine to do this. This is called running or executing code. Now two things can happen. Nothing much, which is probably a good thing, or you get an error. If you get an error, double check that your working directory is correct and change it if needed. Also double check the code. After getting my data into R, I always double check it to see if everything seems to have worked as expected. We can use head and the name of the dataset to see the first 6 lines, or tail and the name of the dataset to see the last 6 lines. If you want to use SPSS data files, there are packages that add this functionality, but we'll come to that in a moment. Let's begin with getting a feel of the data, understanding what's there. We can already do this with the output from head and tail. With names and the name of the dataset, we get a list of variables in the dataset. This can be quite handy. For small datasets, view with a capital V can display the data more like a spreadsheet, but with larger datasets this becomes cumbersome. If your variable names are difficult, you can easily rename them. The code for renaming is the name of the dataset, so dat in our case, followed by the $sign and the new name of the variable, like edu. We then add equal, the name of the dataset and the name of the old variable, like education. This will save a bit of typing, and I often find that renaming variables helps me understand what I'm doing. Let's explore. For a categorical variable, we can use table and the name of the variable in brackets. We always use the name of the dataset and $ so that R knows which dataset you mean, because you can work on many datasets at the same time. This simply counts the number of cases in each category. There you go, data analyzed. For a cross tabulation, we use table followed by the name of 2 variables in brackets divided by a comma. So now we can see how many cases there are in each combination. For a continuous variable, you might want to calculate the mean. That's simply mean and the name of the variable in brackets. What about the distribution? Let's create a histogram with hist and the name of the variable in bracket. Nice. We can use saveplot and a file name like histo.png to save the plot to a file. That'll be saved into your working directory. There are also commands to export graphics directly like PNG, PDF, SVG or TIFF. Let's explore a bit more. How about the median instead of the mean? You've guessed it, median and the name of the variable. Percentages, not too difficult, but you're really starting to program here. Let's start with table to create a crosstab. Rather than sending it to the console, we start the line with tab and equals, so we're creating an object called tab. We can then use this object called tab to do something with it. With prop table we get the proportions, which is just the percentages divided by 100. In the brackets we have tab, our object with a cross tab inside. There's a second argument, margin, telling R if you want 100% in the direction of columns or rows. If the numbers come out differently from what you expected, try margins equals 2 or the other way around. Again, we put it in an object. This time it's called prop, but as with all objects, you're free to choose a name that suits you. Next, we can use round. Yes, to round the table of proportions. The common 2 rounds to 2 digits. Hang on, we want the percentages, not proportions. Let's simply multiply the proportion by 100 and maybe round to 1 digit. There you go. For a regression model, we can use LM, which is built in. Let's use prestige as the outcome or dependent variable. Mod at the beginning of the line is the name of the object we use for the model. Then equals and brackets. In the brackets, we have a formula to define the regression model. The outcome variable comes first, followed by a tilde, and then the predictor and control variables divided by plus signs. Here we have prestige as the outcome, education as predictor, and income and gender as control variables. If we add data equals and the name of the dataset at the end, we don't need to repeat the name of the dataset every time. With summary, we can see the coefficients. To use the Bayesian regression model, we need to install a separate package. That's additional code we can download from the internet. Using install.packages and the name of the package, we can install a package mcmcpack. Pay attention to the spelling. In the future, we can simply use a library to tell R that we want to use a particular package. So library mcmcpack. The way to run a Bayesian regression model with mcmcpack is almost the same than with the frequentist LM, especially if we're happy with the default priors. Here is an object called Bay and summary to see the coefficients. Done. Next time, take your code, modify the reference to the data file, modify the variable names, and you're done. Use comments to help yourself. That's everything after the hash symbol in a line. You may gradually move to more complex approaches, but tables and averages may be all we need. No fluff needed. Get started. Oh, open the SPSS files? Install the package called Haven, and there's a new command read SAV to open SPSS files just like we used read.csv. Just modify the name of the data file and choose a new name for the data. Then you can reuse those commands for the tables, regression models, etc. There you go, plain R. The beauty for R is that you can always add more packages, interfaces and convenience, but often you don't need to.